Hey everybody, and welcome back. Today in this video, we are going to be looking at the important formulas that you'll need to know for vector operations. And so I am currently in the FE handbook, and we're looking at the civil FE exam. And so to get here, if you don't already know, then you want to have the most up-to-date reference handbook. You want to click into your bookmarks and scroll down to the bottom where it says Appendix FE Exam Specifications. Then you want to click on Civil. And now you can see what's going to be on your test. And so we're just focusing on the important formulas for vector operations. So the important formulas here are going to be under the mathematics bookmark. And you want to do a search for vectors. So I'm just going to search vector in the handbook. And the reason why I selected the mathematics bookmark, because typically when I do that, it brings me to the closest section that I feel like I'll need to be in. So there's 40 options here, but this first section is going to be the section that we're really going to spend the most amount of time. So what is a vector? Well, a vector ultimately just measures the direction and magnitude of a particular quantity. So you have vectors and you have scalar quantities. And so I want to share with you the difference between those two, because this could be something conceptual that you get asked. So I'll give you some examples to kind of put things into perspective. Scalar quantities, and I just did a Google search, scalar quantities, they have magnitude but no direction. So that means that, for example, you can have a certain speed, but the direction does not matter. Or you can determine the temperature, the temperature quantity, but it doesn't have direction for you to be able to, you don't need to know the direction of temperature to be able to determine it. For vectors, you do. You need to know both the number aspect, the magnitude of it, but you also need to know the direction of it. So if you're pulling or pushing something with a force, you need to know how much force you need to push on it and the direction that you need to push on it to be able to get it to go where you want it to go. So this is very crucial for lifting weights, right? If you're lifting weights with force, all right, you want to be able to push those weights and get them moving in the direction that you need them to, so that the bar isn't stuck on your neck or you're not getting hurt, right? Direction is very important there. All right, that's just a little conceptual stuff. Okay, so they may ask you to add or subtract vectors. And so this all may look a little bit complicated. So what this is trying to show here is that these little arrows here, if you zoom in, they have direction. So the direction can be going along the x-axis. It can go along the y-axis, and it can also go along the z-axis, right? And so here, this capital A is a vector. So you can see A here is just a vector. It's vector 1. This B here is another vector. It's vector B. Then you got vector C, right? So within vector A, it has an x component, and that's you'll write a I beside it. That's just to note it's in what direction it's going in. Then you'll have a y component, and it's denoted by J. Then you have a z component. It's denoted by K, right? And so if we're adding, if we want to add two vectors together, if we want to add vector A, we want to add that to vector B, then we want to take the x component of A plus the x component of b, and add them together and put an I beside it to denote that it's that piece of it is going in that direction. And so then we want to add the y component of a plus the y component of b and put a j beside it just to note it's happening in the y. So this is all helping us with direction. So you can add vectors, you can subtract vectors in a similar fashion. Another thing to note is there is an angle that is created between vectors, and that is denoted by theta here. And there are two different types of ways that you can get that angle. You can compute dot product, which to me is the easier of the two, or cross product. And we'll do some examples, but basically to get dot product, you need to, it equals, so a dot b is denoted by a dot b. It is going to equal your ax, or your x component of a times your x component of b, plus your y component of a times your y component of b, plus your z component of a times your z component of b. And that's all equal to the magnitude. So what is the magnitude? The magnitude is just your ax squared plus your yx squared. Your magnitude, and I'll just do a quick Google search. So that you can see what it might look like. Yes, so to get the magnitude, you just want to take x, so the x component squared plus the y component squared plus z component squared of a. So a vector A, it has an x component, has a y component, and a z component. To get the magnitude, you just want to take the square root of all of it. Okay. So that is how you get the magnitude. All right, so let's go back to our handbook. So yeah, they make this kind of confusing, but that's how you get the magnitude of A. You can do the same thing for the magnitude of B, and then cosine of theta. Now, in the event that they ask for you to solve for theta, you're going to have to be able to get all of this information. You should get a number. And when you take the magnitude of A, you should get a number. When you take the magnitude of B and get a number. And then you want to get everything on this side and then take the cosine inverse to get theta alone, right? Similar to that, if you want to take the cross product, and the cross product is a bit more complicated, and the handbook does not help us with it. So I've done some videos where I go through how to do that cross product, so you can check those out. But basically, you take the magnitude of B, take the magnitude of A, multiply it by the sine of theta, and that gets you closer to your answer, right? So a lot of variables here that we just have to kind of fight with and go through to be able to get and understand vectors. So I believe that is all I have. Yeah, that's pretty much all for this section, but there's quite a few things that they can ask you. So hopefully this was helpful, and I will see you in the next one.